I'm Andy McCright, and I'm the Web Services Architect at IBM. And I'm here with my colleague and teammate, Adam Anderson, and together we're going to talk to you about MicroProfile GraphQL and JPA and how they are a match made in heaven. So the idea for this session, oddly enough, came from a guide that I saw on the Spring website talking about how easy it is to combine Spring REST with JPA, and I was amazed by the simplicity of it. That guide was probably written 5 years ago, so there's a lot has changed in that time, and GraphQL is starting to fill some of the gaps that are left in REST. And so I felt like we needed to kind of update that guide a little bit and talk about how we can integrate GraphQL with JPA. So first question you want to ask is, what the heck is MicroProfile GraphQL and JPA? Excellent question. Let's start off with JPA. So JPA is the Jakarta Persistence Architecture, or APIs, formerly known as Java Persistence APIs. The name change came about right around the time when Oracle donated the Java EE projects and specifications over to the open source community, and came under the stewardship of the Eclipse Foundation. So JPA is a object to relational database mapping. So basically you get the CRUD operations, create, read, update, delete, but without having to do a whole lot of SQL. JPA is a spec, so it's a specification, meaning that there's different implementations. So the idea here is that you could code to a set of APIs or the specification that's written, but then you might use an implementation like Hibernate one day, but then switch to another implementation like Eclipse Link or OpenJPA tomorrow. And the whole idea is that you should be able to write the code once and run it anywhere. So servers like OpenLiberty, which is what we're going to be talking about a little bit in this presentation, include not only the APIs, but usually include an implementation so that your code, your user application, doesn't have to package the implementation or the APIs that comes with the server. So this is what a JPA class might look like. So first thing to note is this is just a plain old Java object, right? This is just a data structure that has a few different fields, and it has some getters and setters on it. It has a public no-arg constructor. So in addition to that, there's an @entity annotation to tell it that, hey, this is a JPA entity. This is sort of how we denote this as an entity. And then it has an @table annotation to tell us basically some table configuration and table mapping, so we know what table it's related to in the database. The ID annotation here on this field tells us what the primary key is and helps us for finding a particular object out of the database pretty quick when we get to that. So here's how we might use it, right? And here's in our CRUD operations, right? So we have our database and we want to create something, right? So we create a new widget. So we create the widget object, and then we use the entity manager, that's what this EM is, to persist that. At this point, it is now put into the database, and there's a link between the object and the database entity. So let's say we want to go find that object now. So we will look it up by calling the find method on the entity manager, using the widget class and using the primary key 1, 2, 3 that we created up here in our first object. So now we can see that these are the same objects. Widget 1 and widget 2 are the same. So now let's say we want to update it. We want to set the depth to 24.3. It was originally 21.3. So we're updating it here. So we find it, we call the get depth, we call set depth to set it. Then we verify that the get depth was changed by finding it out of the database. And last, to delete it, we just call em.remove and remove that particular object. And then we can verify that object doesn't exist. It's null if we try to find it in the database. All these values, all this text here in blue is the actual SQL that gets generated by the JPA implementation. Cool. So now that we're experts on JPA, what's this MicroProfile GraphQL stuff all about? So GraphQL has been around for a few years. It was invented by Facebook. MicroProfile is a community that runs under the Eclipse Foundation, and the GraphQL project is a Java-based code-first spec for GraphQL. So basically, there's a GraphQL spec, then there's a MicroProfile GraphQL spec. Then, just like with JPA and with other Jakarta kind of and MicroProfile specs, there's implementations. So what we'll be showing you in Open Liberty is actually the smaller I GraphQL implementation. It's annotation based, so similar to JAX-RS for REST, but it's going to so there's going to be a lot of commonality between something like JAX-RS and MicroProfile GraphQL. And like I said before, it's a spec, so there's different implementations. Currently, we support the MicroProfile GraphQL specification supports queries and mutations. If you're familiar with GraphQL, you know that there's a few other things. There's also some cool stuff like subscriptions. There's some client APIs. There's federation. These are things that we've got on the that we've got planned. Some of it's under construction in the small right community. So a lot of these things are coming soon. But just real quick, in case you're not familiar with GraphQL, one of the key advantages that it has is that it basically tries to address some of the shortfalls in REST, like underfetching and overfetching. So in a previous presentation, I've talked about how you might want to go and find what the weather forecast for your area is by going to like AccuWeather.com and issuing a RESTful request. And I kid you not, you will get 10 pages worth of weather data for your area. And it's all in JSON, so it's already pretty minimized. It's so much information. And if you're only interested in just getting what the temperature is, well, you've got to basically sort through all those 10 pages to figure out what the temperature is, so you know whether to bring a jacket or not. Well, then if you wanted to do that, you wanted to look up your own location and 2 or 3 others, now you've got to wade through 30 or 40 pages worth of JSON to get the data you want. GraphQL allows you to basically get the same data, but get it exactly what you want. So if you just want to know what the temperature is, or if you just want to know if it's going to rain, you can issue that request, tell it exactly what you want in the query, and get that data back, and you reduce your network bandwidth significantly. So this is what you might do if you're going to write GraphQL code. You have a greeting object, which is just a POJO, similar to our entity in the previous slides. You have a GraphQL API annotated class with an annotated method with @query. This allows you to pass in parameters like one called name with a default value of world, and then you can return return the POJO, and that's all the code that you have to write. Then when you run a query, you can run a query like this one here, where we run it in, basically we want to do 3 separate queries, one in English, Spanish, and German with different names passed in. We get a data object back with the results of all 3 of our queries. So we have one query, basically one round trip to the server gets us 3 pieces of information and exactly what we want. So we don't have to see what the Spanish version is when we're just interested in the English one, or we don't have to see the German version when we're looking for the Spanish version. So GraphQL is pretty slick. MicroProfile GraphQL is pretty slick. So now that we're experts at that, let's get to the challenge. This session is not for the weak at heart. Our challenge is to develop a car dealership network. So we want to create a proof of concept application that will allow car dealers, basically our users, to advertise their inventory. The idea here is that dealer 1 might have a customer who's interested in a car, but it's not on their lot, it's on somebody else's lot. But they need to know that dealer 2 has that car, and work out a way that they can acquire that car for their customer or refer them for some kind of fee. So they've got to be able to upload their current inventory and make them available to other dealers. And this application, it'd be really great if you could have a presentation ready to go to show to upper management by let's say by the end of the day. Otherwise, I might have to have you come in on the weekend, or relocate you to storage room B. So let's see how we can do it. Adam, I'm going to turn this over to you.
Boy, that's kind of a tall order, Andy. I guess the first thing I'm going to need is I'm going to have to create my project. So I'm going to head over to the start.microprofile.io site here. That's going to give me a quick and easy way to just download a Maven project with everything I need. I just got to give it my group ID and my artifact ID. select which MicroProfile version and Java version I want to download. I'm using the Open Liberty runtime, and I can even pre-select GraphQL to get things configured. I download that, and it's going to give me a zip file that I can unzip, and there we go. There's my project structure, including my Liberty configuration with the server XML, my Palm XML, my packages, and a couple Java classes to get started with, and a few other goodies. So we've got our project. Let's take a look at the Palm XML here quick. So don't be intimidated. All this stuff was generated for me by that starter. So there's not too much I actually have to do. Namely, I have to download my I have to specify my dependencies, and I do that as I build the application. So here's my final one. You can see a couple things like specifying my Derby version and my ports for Liberty. And then adding the GraphQL dependency, which was already added because of that box I checked. I also, added the CDI, the Derby, the JPA, and the transaction APIs as well from Maven Central. So our product is set up. We're going to need a data model. We're doing a car dealership, so we need to know about cars. That's going to be the core of our application here. What's a car? We've got our vehicle identification or VIN number, your make, your model, your color, what year it was made. For a little extra, we can put how many doors and seats it has, how much horsepower it has, if it's a convertible or not. We're going to need to know how much it costs, and let's give it a dealer ID so we know who has this thing for sale. So this is our basic data model. With a few annotations, like Andy was saying, we can, have this automatically flow to a database. We've got our entity annotation here, saying that yes, this car class is our entity. We name our database table with this table annotation. We're going to skip these name queries for now, but we'll get back to them. We use the ID annotation to set the VIN as the primary key. And we use the column annotation to label each field with a column to map to in the database. In this case, we're just going to use the automatic generation type for our primary key to keep it simple. And we've got a few GraphQL annotations in here as well. Namely, we can use name to give a custom name separate from the field for the GraphQL service. We can also use this non-null annotation to specify that this field can't be null. Since we have a string for our primary key and strings can be null, we want to let the GraphQL client know, hey, this can't be null. Don't do that. Another cool thing we can do is we can ignore fields if we want. So just for demonstration purposes, we've got this internal code integer, and we've slapped the GraphQL ignore annotation on it. This is similar to like a JSON ignore annotation where GraphQL will completely ignore this. It won't have any idea it exists. It's not going to be exposed to your client, and you can, have underlying stuff that's not visible. We do need to have just a default constructor, and we also need a parameter constructor to initialize each of the fields when the GraphQL service creates a new car. We can also create an enum and use the GraphQL enum annotation to define the enum in our schema, so the client knows about it. And in this case, we're limiting which colors. We're using it as like data validation for which colors the cars can be. And then we've just got boilerplate getters and setters for each of the fields. And then at the bottom, we also have the ignore field on the getters and setters for the internal code. So now that we have our data model all defined and set up, we need to configure our persistence layer. If the core of your JPA configuration is this persistence.xml, might be kind of hard to see, but if you look on the left and squint, maybe you can see it's in the meta inf directory. And what this does is it lets us define a persistence unit. In this case, we're naming it JPA unit, And since we're running in a container, we are limited by the spec to JTA. And we are specifying the excuse me, we're specifying the JNDI name of the data source as defined in our server XML for Liberty. If we switch over there quick, we can see we configure our Derby library, and then we create a data source with an ID. Here's that matching JNDI name that I was just talking about, and then we can specify the Derby library to use. We name the database, and then create it when the server runs. Switching back to our persistence XML, we've got a couple properties here. Liberty uses the Eclipse link as the implementation for JPA. So these properties allow us to create the database automatically when we first run the server instead of having to go through that process manually. Touching more on the Liberty config real quick, we use these features, the CDI 2.0, JPA 2.2, and Mp GraphQL 1.0 features to enable the implementations for these different specs. And we define our application with our context root, and we're good to go. So now we have our data model, our persistence layer configured, and our server configured. Now we're going to need what's known as a data access object. This is kind of the layer where we create our CRUD operations to use with our data model. So I created this car DAO class, and we use this persistence context annotation to inject the entity manager, and we get the name of the persistence unit that we defined in the persistence XML. And that's kind of the glue wiring it together. So here you can see I've created a couple CRUD methods using the em_persist, em.find, em.merge, and em.remove, like Andy was talking about. And for a little extra power, I have these named queries that I'm invoking. If we switch back to our data model, the car, at the top, I have these two named query annotations, find all cars and find all convertibles. We give it a query string, and you might notice that this looks pretty similar to SQL. It's actually JPQL. It's similar to SQL, but as defined by the JPA spec for use with JPA. This is going to give us that expanded functionality beyond CRUD operations if we need it. So we have the option if we want to use it. In this case, we're going to return a list of cars where we just get every car in the database. And then for convertibles, we're going to return all cars as long as the convertible field is true. Pretty straightforward. We go back to our DAO. You can see we create the query, and then this get results list is going to invoke that query and then collect the results and return them back. So now we've got our DAO set up. We're most of the way there. We just got to create a GraphQL service. So I create this GraphQL service class, and as Andy says, it's gonna parallel JAX-RS and REST really closely. We use this GraphQL API annotation to mark the class as a GraphQL endpoint, and we're going to use CDI to inject the car DAO, named inventory in this case, and then we've got all these methods that are annotated with either query or mutation. These are our GraphQL endpoints. Queries are an equivalent of like a JAX-RS or a REST GET request where you're just getting information from the server. A mutation is anytime you're modifying information on the server, such as a post or a put or a delete. So in this case, we've got a lookup car query. We've got the optional description annotation, which is documenting the query for our client. And we're using the transactional annotation, which ensures that the methods run within the boundaries of an active global transaction, which is why we don't need to explicitly begin, commit, or roll back transactions. So less code we have to write. Super simple. You can see here where we're using the name annotation for the VIN again, just like in our data model. And we've got a few few queries and mutations matching up to our CRUD operations, and our named queries as well. One thing I wanted to point out, what with this get all convertibles query, is that we can return partial results in the case of an exception. So I get my list of convertibles and then I iterate through it doing color matching. And for some reason, if an exception is thrown, I catch that exception and then I throw a GraphQL exception back to the client and I pass it my partial list of cars that I've already calculated. And then those partial results get returned because I've already done the work. I might as well. So that's really handy. So that's all that was there to it. So let's start the server. We're gonna just simply do Maven Liberty :run from our project directory. It's gonna take about a couple seconds. It's gonna run the server. I'm gonna get a message saying the server's open for business in 2 seconds. There we go. Default server is ready to run a smarter planet. We're up and running. So if I open a web browser and I go to my context root /GraphQL/schema.GraphQL, and this is defined by the MicroProfile spec, I can get my schema here in my web browser. So if I need to know what sort of requests I can send, I can look at this and that tells me exactly what I need to know. Here we can see my data model, my car. I can see my list of documented mutations and their inputs and returns types. Same with my queries. There's that enum I defined on my data model, and then the input that's used with my queries and mutations. So if we switch back to my server XML real quick, there's this variable io.openliberty.enable GraphQL UI with a value of true. This is going to allow me to use a built-in graphical user interface to execute GraphQL queries from my browser for testing purposes. So in this case, I've already pre-populated a little bit of data. So let's look up a car with the VIN number LC0001. I'm only interested in the color, the year, the make, and the model. I don't care how many doors it has, who has it, how much it costs. I'm just curious what this car is. We run it here. And oh, it's a red 1974 Lamborghini Countach. Pretty sweet. But what if I want to know how much it costs? Can use a little autocomplete here, add that field, and now it's giving me how much it costs. Again, it's giving me exactly what I want to know and no more. And that's important when you're running in a cloud environment and you're paying, by bandwidth. If we can just minimize the payloads to just what we want, it makes it easier for the client to parse. We're golden. Here we can run the named queries. Let's get a list of all of our convertibles, regardless of color here. There we go. So here's all my convertibles. Some pretty sweet cars, if you ask me. I wonder how much horsepower they got, and what's the dealer ID, so I can see who I need to contact to buy these things. Well, there we go. There's all that information right there. Pretty dynamic and simple. And we really didn't have to do too much coding. I think we made it by the end of the day. What do you think, Andy?
I think so. So we're done, right? So
Woohoo, we did it.
So I think there's a little bit more to the video that we didn't get to put out there, but the good news is that we completed our mission, and so I'll just try to sum up what we talked about. With GraphQL, it's very easy to present to the web or to via HTTP clients a lot of information, but allows the clients to get just what they want, right? Just to avoid that underfetching and overfetching. It also allows us to interact with APIs like JPA that are very common for databases, and allows us to take advantage of that. I'm seeing a few questions come in, so I'm going to start answering those. First question, looking at stuff like Hibernate, which proxies classes for lazy loading. Does GraphQL filter the data after or before being serialized? It actually does it after it's been serialized from the database. So basically, what will happen is when you return your object from your GraphQL method, from your query method, or from your mutation method, at that point, the GraphQL implementation is going to serialize it and return back only the fields that the client requested. So the advantage of that is you can do one database lookup for, like in our example, for a particular car, look up one car's information and keep that in your JVM heap in memory. And then if another request comes by and says, hey, I'd like to know more about that same car, but I'd like to have more information, right? Maybe get the VIN, or maybe get more information about the color or whatever. You can still get that information. You haven't lost it. It's still in memory. And so it's very efficient as far as retrieving exactly what the client wants. Let's see. Next question I see is what implementations are available for MicroProfile GraphQL. So implementations are a little funny, right? So there's the actual implementation that just implements the GraphQL specification. For those, I'm aware of two. There's SmallRye, which is what we used, what we demonstrated today, and then there's also one by Oracle. I'm not sure exactly what the name is. I think it's Helidon GraphQL. But both of those, so those implementations are typically then packaged with an application server. So, for example, the Helidon one goes with the Helidon application server that's produced by Oracle. SmallRye is used in OpenLiberty, which is what we demonstrated today. It's also used in Quarkus and Wildfly. So if you go and download any of those app servers, you'll have an implementation of GraphQL, and I believe there's more coming too. I don't think it's just those four. Would Mp Graphql work with other data stores like Nosql? Yes, absolutely. GraphQL is great when it comes to, I mean, basically the way it works is you return an object. That object gets serialized into a format that's accessible by the GraphQL client, whether that's a web-based client like what Adam demonstrated, or whether that's a more programmatic client. So you return an object, it serializes it and filters it down to exactly what the client requests. Let's see. So yeah, going back, the backend data store could be SQL accessed with JPA, could be NoSQL, could just be a hash map in memory. It's pretty simple. I see a question. Is the schema first approach also supported in any way? Not with MicroProfile GraphQL. You can use a schema first approach by using GraphQL Java. And I believe I think SmallRye and Helidon both use GraphQL Java as an underlying implementation for doing some of the GraphQL processing. So you could use that. It's a little bit more low level, and it's something that we have talked about adding to the MicroProfile GraphQL spec. So if that's something you're interested in, I encourage you to jump out on GitHub and start raising issues or commenting on issues for that, because that's something that we have talked about as far as a future feature.
Specifically, like our most recent meetings, spec meetings have been had a large discussion around this, and so it's something we're actively looking at. And yeah, if it's something that interests you, let us know.
All right, last question I see is Mp GraphQL expected to become a core spec or remain a standalone one? It's standalone for now. It is planned. Well, there's discussions ongoing right now in the MicroProfile, in the larger MicroProfile community, to discuss integrating that as part of the core specs. So I guess stay tuned, and if you have strong opinions, now is the time to talk on the MicroProfile mailing list to kind of express your support for MicroProfile. I don't see any other questions. Let me just say one thing. There's a lot of information in a book we wrote. It just came out last month. And if you're interested in it, follow me on Twitter. I think that my Twitter link should be on the in the chat. If you do that, then post some feedback about this session. Tell me something that you really liked about it, something you don't like about it. Give us some feedback. Obviously, we'd like constructive criticism if there's something we can do better. But give me some feedback. We'll randomly take 3 people that tag me and tag EclipseCon, and we'll get 3 copies of the book out to you. I need you to follow me though, so I can direct message you and get your contact information. But if you're interested, that's available. And if you don't get a free one, look it up on Amazon. I think it's a great resource.
Thanks, everybody.
Yeah, thank you so much.